Lesson 11-2, Areas of Circles and Sectors. By the end of today's lesson, we will be able to find the areas of circles and sectors. The sector of a circle is the region bounded by two radii. So if I have a center O here, and I draw two radii, and bounded just means it's going to be inside these two radii. So this region bounded by two radii of a circle and their intercepted arc, so I could label A, B, so this would be considered the region, is called the sector of a circle. It's like a piece of pie. Okay. Theorem 11.9 is actually the area of a circle, in which all of you should know by now. The area of a circle is pi times the square of the radius. So just a quick review. Area equals pi r squared. So example 1, let's do some review. Find the indicated measure. Area, pi 4.2 squared. Using your calculator, should be about 55.42 meters. And we want to find the diameter for the next one. So 201 equals pi r squared. So we're given the area. So your radius should be about 8 inches for r. So the diameter should be double 8, so about 16 inches. And please label your units precisely. In the next one, we're given the diameter and we want to find the area. And so we need to take half of 9, which is 4.5. So area equals pi 4.5 squared, which is about 63.62 centimeters. And for this one, we want the radius, 154 equals pi r squared. R would be about 7 feet. So you can go ahead and use your calculator to double check these answers. Theorem 11.10, the area of a sector. The ratio of the area of a sector of a circle to the area of the whole circle. So area of a sector of a circle to the area of the whole circle, pi r squared, is equal to the ratio of the measure of the intercepted arc to 360 degrees. So this formula looks similar to the last one in lesson 10.1, except for this part where it's referring to the arc sector, the area of the arc sector versus the length. So we can also rewrite this as the area of the sector APB, this part, is equal to the measure of the arc length bounded by the two radii, so this part, over 360 times pi r squared. Example 2, part A. Find the areas of the sectors formed by angle RQS. So I know that the arc measure of the arc is also 60 degrees given the central angle 62 degrees. So I'm going to do 63 over 360 times pi and then r squared, so my radius is 5. Again, you can go ahead and use your calculator. It will be about 13.74 square units. And then part B, we'd like you to practice one more time. Find the areas of the sectors formed by angle RQS. So we know this is 106, sorry, degrees. So we can go ahead and do 106 over 360. Again, I'm using this formula here, times pi, and then r squared, which is 9 squared. And this would be about 74.93 square feet. Example 3. Use the diagrams below to find the area of circles C and G. So now we're given the area of the sector. We want to find the area of the entire circles. So we have 22 equal to 45 over 360 times area of circle C. So this part used to be pi r squared, but we're not worried about using pi r squared. You can just go ahead and let this be like an x. So after using your calculator to find out what the area is, you should get about 176 square meters. And for the next one, same thing. This is the area of the sector. By using a formula, we can do 6.4 equal to 80 over 360 times x. So x would be the area of circle G. So x should be about 28.8 yards squared. Example 4. A contractor needs to cut a section out of a rectangular piece of wood as shown. To the nearest square inch, what is the area of the remaining wood? So I need to first calculate the area of the entire rectangle, which is just taking 11 times the total of 4 and 3. So that's 77. And I need to subtract this white area. So I know I have a square, 3 by 3. So the area of the square is 9. And then I have half a circle. So I can go ahead and use the formula 180 over 360, because this is half a circle, so it's 180 over 360, which is just half. And pi times r squared plus 9. And I can go ahead and simplify this. 77 minus 3.53 plus 9. And this should be about 64.47 square inches. Example 5. Find the area of the figure below. So I have a triangle and half a circle. Half times base times height for the triangle, plus I'm going to use the area of a sector formula, 180 over 360 times pi times 3.5 squared, or you can simply look at it as half a circle. Half times pi r squared, that's fine too. And we will have 14 plus a new calculator, be about 19.24, and this will be about 33.24 square feet.